So my name is Roope Astala. I'm from the Microsoft Azure machine learning team, and I'm here to talk about our service. So who has heard about machine learning? Who has heard about Microsoft Azure? Who has heard about Microsoft Azure machine learning? Okay, good. So what Microsoft Azure machine learning is, it's a cloud-based platform for building machine learning models and putting them into production. So in this talk, I'm going to go through different things you can do with our service and discuss a bit about the algorithms we have and what kind of capabilities we have. So the service is really made of two components. There's the machine learning studio. You can see its landing page up there on the screen. That's the place where data scientists build machine learning models. And then there's the operationalization service, which is the place where you put these models into production on a cloud as an elastic request response endpoint or a batch scoring endpoint. So with that, let me show you how this thing works. So there's a concept of experiments which are the machine learning models. So I'm going to create here a new experiment to show how this works. And what we will do is we will try to predict from census data whether a person earns more or less than $50,000 a year. So we have here the data set. So we drag and drop this to this canvas where we're building our model, and we can take a peek at this data set. So here we can see different demographics features in different records, and what we are trying to predict here is the last column, the income. So what do we do first? Well, first, of course, we split the data into test and training data sets. So I'm going to grab here some split and drag this module into the canvas and connect it to a data set. And then we'll pick the fraction we want to use for training. We're going to use 75%. And let's click here and run. And it goes. It went, scheduled this module, this experiment to run on a cloud, and it executed it. And then we can start building do the actual machine learning. So we'll need to, of course, train a model. And we want to pick what kind of model we are going to use. So usually boosted decision trees are pretty reliable, so let's pick that one. And then we have to pick what we are trying to predict. It was called income. Here we go, and we can run this experiment. So now you can see that it remembers I already run the split, so it only run the modules that I added to the model. So you can kind of incrementally keep making your model more and more complicated as you go along. And then now we have a trained model, so we want to score this model against our test data from the other half of the split and evaluate the quality of the model. So we'll need evaluate. We'll run this too. Here we go. And we can take a look at the results of the model and see if it's good. So here's the AUC curve that shows the false positive versus true positive rate. So say if we are happy with the, say, 30% false positive rate, we will get about 95% of the true positives. We'll see other metrics of the model, the accuracy, precision, recall, and other metrics. So now let's say we are happy with this model and we want to actually publish this as a web service that you could say call from your desktop app or from a mobile app or from your enterprise production workflow. So I'm going to do a couple of changes to this model to prepare it for the operationalization. So I'm going to save as, let's call it income scoring. So we've already, actually let me go back. Let's just rerun this. So what we're going to do is we're going to save this trained model. Let's call it income model September 14th. And then we don't need to train it anymore. We don't need this one here. We actually don't need the split. What we need to do is remove the column that we are trying to predict, which is the income. So we begin with all columns and exclude the income. Connect it to score. We don't need to evaluate. We did that already. And then we need the actual saved model. And let's try running this. Okay, so that's finished, and we can take a look at the output from the scoring. So now here we have the results, the scored label and scored probabilities. So there's a little problem here because now we are sort of echoing back our feature vectors, and for request response endpoint, that's not ideal. So we'll put another project columns here. And we only pick the scored labels and the scored probabilities, basically what probability this model assigned for the given prediction. And then we set the input to the score as a publish input and set the output as a publish output. I have to run this model one more time so it sort of collects the necessary schema to actually publish this model as a web service. Here we go, now we're good to go. We just click publish as web service. And there we go. We have a request response endpoint that's elastic, scalable, available on Microsoft Azure Cloud. And we can test this out. Just give it the default inputs and see what happens. And we can see it made a prediction that in the default case is what you see here. So now this is good for testing it, but actually to put this, call this endpoint from some other application, we need to do something else. So let's go to this API help page here. So there's actually a sample code in C#, Python, and R that we can try out from our local PC. So let me just open a Python editor here. And copy paste this piece of code in here. And then we need the API key. And now, people who are viewing this recording, if you don't even think about scraping the API key. This service will be long gone by the time you see the video. And we can run this. Interesting. So yeah, okay, I see. Yeah, so I need the first line. Thanks. Okay, and here we go. It gave the prediction. So now you can see you could take this. This is all using JSON and REST APIs. So you could take this. So now you could take this model and call it basically anywhere. Let it be a mobile phone, a PC, or something completely different, as long as it supports this particular protocols and use this machine learning model. So you can see there's actually two different kinds of API here. The request response, which is sort of the low latency type of service where you send the model one record, it scores, it comes back with the response. So this is good for, like, say, scenario you're trying to detect credit card fraud. Someone makes a purchase, you send the information to the service, and then it gives yes or no. Should I should I allow the transaction or not? And there's also batch execution service, which is sort of more of a higher latency, but also higher throughput, where you can give it an entire file of records and get them all scored in a one fell swoop. So now this service is what we call in a staging mode. So what you can then do when you're happy with this model is to promote it actually to production. And the difference between the production and staging is that in a staging mode, the service is throttled at the 2 requests per second. When it's ready for production, the limit is something much higher. And now here's now what where we actually went here is the Microsoft Azure portal, which is sort of like the top-level portal for all the Azure services. You can see there's all sorts of things like, say, if you want to build different kind of services in Azure available here, but we are specifically interested in the machine learning. And here, this is sort of like the place where you manage these workspaces if you're an IT admin, and also where you manage the web services. So now the web services that have been promoted to production appear here, and this is where the IT admin can manage them, add, delete them, and monitor the usage. So that's sort of like a hello world type of demonstration how the product works. So let's look at some of the other capabilities that we have here. So we'll go back to the machine learning studio. So there's a number of algorithms that are available. So let's say let's say you don't want to use some of these standard datasets that have been uploaded here. You want to use your own dataset. What you can do is you can either upload from desktop or you can use something called Reader. This is a module that lets you pull in data from different external sources like public HTTP different Azure storage services, and also if you're not using Azure, you can also do Hive queries against generic Hive servers. So these are good ways of getting data in. And there's also a similar counterpart called write that lets you write data out from your experiment. Now, a question we often have is that what if I want to do something very custom on my data that is not easily expressed as any kind of canned module? So what we have is support for R scripting. So you can connect your data to R script, and then if I can make this a bit bigger, do different data manipulations, data plotting as part of your script. And currently it's we have execute R script, and in near future we'll have execute Python script. So that's that. And let's look at the actual algorithms a bit. So we've been focusing on classification and regression algorithms to begin with. So we have support for all the standard algorithms like a decision forests, SVMs, linear regression, logistic regression, and then there's also some bit more exotic ones that come from different groups at Microsoft Research. So basically, like, our product is almost acting as a hub for these different research groups within Microsoft to bring their algorithms and give them to customers. And so there's a similar list for classification and regression. There's also algorithms for text processing. So we allow you to do feature hashing, and here's an interesting module called name entity recognition. So this is something that if you have say a large body of articles, and you want to recognize entities such as people, companies, or places from that data, you can use the name entity recognition to do that. And this module has been trained against some huge data set that belong to the Bing team. So you kind of get the benefits of those data sets by using this module. And let's look at another interesting example. So what we have here, is a list of sample experiments that cover different scenarios. One scenario that I want to specifically talk about is recommender systems. So here is a machine learning model that tries to give restaurant recommendations to customers. And this works with different data. So if you're not familiar with recommender problems, let's go through that quickly. So basically, we have triplets of users. These are the people who go to the restaurants, the places, the place IDs, the IDs of the restaurants, and then the rating that the customer gave to that restaurant. This is on scale from 0 to 2, and you can see that not every customer has predicted every restaurant. Actually, this data set is very sparse. A typical customer only went to few restaurants that they rated. So this is sort of similar to like what you would see at say Yelp, or if you were looking at movie recommendations at Netflix. And the problem we are trying to solve is given this sparse data set, how do we fill in the blanks? Like a customer goes to the new restaurant, what would be the rating that he would give to that restaurant? And based on that prediction, we can make we can make some interesting decisions about which restaurants to recommend to which customers. And we also have some contextual data about the customers themselves, where they live, whether they are smoker or non-smoker, what is their dress preference, like what kind of credit cards they have, and things of that sort. So so using this data, we go and train a recommender model. So here we are using an algorithm called Matchbox, which is actually a sibling of the algorithm that powers the Xbox recommendations. So it's a pretty nice algorithm, and it can predict four different kinds of things. It can predict it can make a rating prediction. What would be the rating that the user would give to a given restaurant? It can recommend. It can actually give a list of recommended restaurants. It can also give item recommendation, which is say a customer liked restaurant X. Give me a list of restaurants Y, Z, and so forth that should be recommended next. And there's a similar recommendation, find similar users. And you can see that this is also a mix of what's called collaborative filtering and contextual recommendation. So it uses the collaborative filtering type of approach based on the rating data, and it uses the contextual data. And sort of compare these two approaches. The contextual data is useful when you are sort of bootstrapping your recommender system. You are starting a new service and you might not have lots of rating data available. But then when you collect more and more of the rating data, then the collaborative filtering kicks in and makes your model much more accurate. And we can take a look at the results of this model. So it reports a metric called non-discounted cumulative gain, and in this case, you can see the value. It's about 0.92. So that sort of explains the machine learning capabilities and algorithms that we have available. What you can also do is you can share these experiments with other people on your team. So what you can go is you can invite other users to your workspace. So then they can see the experiments you have, and you can work together on building them. Another thing is that there's actually no limitations on how many workspaces a user has. So you could, for instance, have a public workspace that you share with everyone on your team, and then you have your private workspace where you keep your super secret Kaggle-winning model. So that's that. And I'm going to show a couple of web links to sort of show how to get started with this. So if you just type in Microsoft Azure Machine Learning, you'll get on our landing page on the Azure service where you can go ahead and I think there's some kind of a free trial available where you get some amount of Azure credits to use it for a month, and there's also Microsoft Azure Machine Learning Center. And this is more of a technical resource. So there are tutorial videos as well as set of featured models. In view more. And you can take a look at this. If there's something that's similar to what we are working on, you can try it out. And finally, this product is built by a team that's actually located in this building on the first floor. So the machine learning studio parts that you saw are actually built here in Cambridge, and there's another half of our team that's located at the Microsoft main campus in Redmond that builds the operationalization components, and that's what I had today. Any questions? So the thing about so the question was whether we have stemming and tokenization and things like that. So currently we don't have a canned solution for that. You could use R scripting to do something like that. A lot of people have asked for that actually, but we just don't have a canned stemming algorithm available now. So. Okay.
How do you charge for this? Is this just an add-on to sell storage and CPU?
Yeah. So for the experimentation, step back. So you get charged by usage. So you don't sign up for an annual license or anything like that. It's
not an extra charge for the machine learning module.
Yeah, so for the experimentation when you're building the model, you get charged for the CPU usage and the storage. When you actually build a model and put it into production, then there's some cost associated with each of the API calls you make. That somewhere there's actually a link to the billing pricing details. So yeah, so here we can see that it's some fraction of a cent per each prediction your web service makes. Okay. Any more questions? Okay, good. So thank you for your time. Looks like we're ahead of the schedule a bit. So. Yeah.